We're in 9.1, which is matrix solutions to linear systems. Here are our objectives. I want to draw your attention to the last objective. It did say use matrices and Gaussian elimination to solve systems. Instead, we're going to be using matrices and a calculator to solve our systems. So matrices are used to display information and to solve systems of linear equations. A matrix, or plural matrices, is a rectangular array. The information is arranged in rows and columns and then placed in brackets. The values inside the brackets are called the elements. So here is an example of a matrix. These are the brackets that we speak about. So the information is contained inside the brackets, which means 1, 2, 3, and 4 are the elements of the matrix. The first step in solving a system of linear equations using matrices is to write the augmented matrix. So the first thing you have to do is go from a system of equations into a matrix. Now, an augmented matrix has a vertical bar separating the columns of the matrix into two groups. The coefficients of each variable are placed to the left of the vertical line, and the constants are placed to the right. If any variable is missing, its coefficient is a 0. Here are a few examples. So here's the first example. So let's call it example 1. And we start off with a system of equations, and there's 3 equations, right? And there's 3 variables, x, y, and z. So we're going to write this system as a matrix. So if you allow me, let me write it down here. Here are my brackets enclosing my matrix, right? This is the vertical line that they speak about. Now I like to draw mine dashed, but it's still a vertical line. To the left of it are my coefficients. So let this be the x column, the y column, and the z column. And I will write the coefficients here. And then to the right of the vertical bar are the constants. So you can treat this vertical bar as if it's the equal sign. Okay, so here we go. The first equation says 3x plus y plus 2z equals 31. Well, this is the x column. This is the y column. And the last one is the z column. So the first coefficient we see is 3, so we put a 3. The second is a 1 on the y and a 2 on the z. So this becomes 3, 1, 2. Here's our equal sign. So there's that vertical bar. Equals 31, and there's the constant 31. And then you see it continues 1, 1, 2. Vertical bar, 19. 1, 3, 2. Vertical bar, 25. So you can rewrite this system using the augmented matrix with the following elements in it. Alright, here's example 2. This time the first coefficient we see is 1, 2, negative 5. Vertical bar here, negative 19. Now here we missed the x variable, so if we were to put it in, it would be 0x plus y, right? Which means the first coefficient is a 0, the second's a 1, and then a 3, vertical bar, 9. For the last equation, we're missing the x as well as the y. So if we fill them in with our zeros, we have 0, 0, 1, vertical bar, 4. Alright, let's go in our books to page 875. We're going to start by looking at number 7, then going to look at number 9. Number 7 says, write the augmented matrix for each system of linear equations. So let's write out our system of linear equations. It says 2w plus 5x minus 3y plus z equals 2. And then we have 3x plus y equals 4. So I'm going to line up my variables. So it says 3x plus y equals 4. In the places where I have missed variables, I'm going to put a 0 and then that variable. So 0w plus sign because 3 is positive. And I'm going to add 0z at the end. Okay, and then we have w minus x plus 5y equals 9. So leave some space and fill in 0z. And the last one is 5w minus 5x minus 2y equals 1. And again, let's put in 0z. Now let's write our augmented matrix. So first thing, I like to start with a bracket. And we know the first column is going to be w. Let's just keep it in the order that we have here. W, x, y, z, and then your vertical bar. And again, I like to make mine dashed. It was just when I was taught it, it was dashed. You can make it dash or solid. They mean the same thing. And then over here we have the constants. All right, so for the first equation, our coefficients are 2, 5, negative 3. Be careful of the sign. Positive 1. So it goes 2, 5, negative 3, positive 1, equal sign, equals 2. And let's fill in the rest. 0, 3, 1, 0, 4, 1, negative 1, 5, 0, 9, 5, negative 5, negative 2, 0, 1. Let me extend out my bracket and close it off. And this is our augmented matrix for this system. All right, let's go to number 9. Number 9 says, write the system of linear equations represented by the augmented matrix. Use x, y, and z, or if necessary, w, x, y, and z for the variables. So depending on how many columns you have, that's how many variables you need. So for number 9, we have the following augmented matrix. And it's 5, 0, 3, and then negative 11, and then 0, 1, negative 4, and 12, then 7, 2, 0, and then 3. So now instead of going from a system to an augmented matrix, we're going to go from an augmented matrix into a system. So since we have 3 columns here, so it's how many columns to the left of the vertical bar? 1, 2, 3. So it's going to be x, y, z. If it would have been 4 columns over here, we would have had a w, x, y, z. Alright, so now we're just going to fill it in. So for the first row, we see a 5 in the x place, so that's 5x plus 0y plus 3z equals negative 11. Remember this vertical bar right here means equals, and these are the constants. Alright, for the second row, we see 0x plus y minus 4z equals 12. And then we have 7x plus 2y plus 0z equals 3. Now, if you wanted to, every place you have a 0, you can just ignore that part. So this answer works, or we can write it as 5x plus 3z equals negative 11. Y minus 4z equals 12. And then we have 7x plus 2y equals 3. Alright, so let's talk about a little bit of matrix row operations. So matrix with 1 shown on the main diagonal and zeros below the 1 is said to be in row echelon form. We use row operations on the augmented matrix to produce a matrix in row echelon form. So here's an example of row echelon form. This is your main diagonal, and I have ones here. If we look below them, we have zeros. Here are rules for your matrices. Now remember, your matrix is just like a system of equations. So everything you can do to a system of equations, you can do to a matrix. So the first one says 2 rows of a matrix may be interchanged. That's because you can interchange 2 equations in a linear system without changing anything. For example, I can have x plus y equals 2, and I can have x minus y equals 5. This could be my system. Well, I can write it as x minus y equals 5 and x plus y equals 2. I interchanged the rows without changing the system. You can do the same thing with the matrices. The elements in any row may be multiplied by a non-zero number. That's because we can do the same thing here. We can multiply this top equation by 2, which means we multiply each by 2. You can do the same thing inside a matrix. The elements in any row may be multiplied by a non-zero number. And then the third one says the elements in any row may be multiplied by a non-zero number, and these products may be added to the corresponding elements in any other row. So let me erase a little bit. Let's make this a 2y. And let me move this out of my way for a second. So the third tells us that we can multiply any element by a non-zero number and then add it to the corresponding element in any other row. So I can multiply the top equation by 2, and I get 2x plus 2y equals 4. And then I can add it to the second equation, right? That's how we solve systems of equations without matrices. So we can add it, and we would get 3x, these would cancel, equals 9, and then we can solve for x, right? So that's what they're saying in part 3. You can do exactly the same thing you do for a system, you can do for matrices. And then it says 2 matrices are row equivalent if one can be obtained from the other by a sequence of row operations. So let's look at some notation. So the first step, or the first rule, said we can interchange the elements in the ith and j row. This is their symbol notation. R sub I interchanges with R sub j. So for example, I can say the first row interchange with the second row. Flip them, right? Number 2 says multiply each element in the ith row by k. So here's the notation. And here's the example. I can say 2 times every element in the first row. Remember, the sub 1 means first row. And the sub I means the ith row. And sub j means the jth row. And then the third one says add k times the elements in row I to the corresponding elements in row j. So like we did in my mini example, I had 2 times the first row plus the second row. In this case, we have to remember our order of operations. Remember, we multiply first, and then you would add second. And this right here would become the new second row because you're adding it to the second row. Let's put another example. What if we had 3, let's say it was negative 3 times the second row plus the third row. So the first thing you would do is multiply the second row by negative 3. That's the first thing you would do. And then the second thing would be to add to the third row, which means once you're done doing all of this, whatever this result happens to be, it will become your new third row because you're adding it to the third row. You're making changes to the third row, the very last step. All right, let's look at examples. So again, page 875, number 15. It says, perform each matrix row operation and write the new matrix. So number 15, let's start by writing down that matrix. And let's check 1, negative 3, 2, 0, 3, 1, negative 1, 7, 2, negative 2, 1, 3. And here are our operations that they want us to perform. Okay, so order of operations says you do multiplication first. So we need to do negative 3 times row 1. So let me write it down here. Negative 3 times row 1. Well, here's row 1, and every element in row 1 is going to be multiplied by negative 3. So that's going to become negative 3, 9, negative 6, 0. And then leave a little space in between, because remember, we're not adding or subtracting these, we're just changing these elements. So negative 3 times row 1 becomes negative 3, so that's 1 times negative 3. Negative 3 times negative 3, 2 times negative 3, and then 0 times negative 3. And then it says you're going to add that to row 2. So let me write row 2 underneath it how it was before in the beginning. So 3, 1, negative 1, 7. And it says we're going to add these two pieces, right? So put that plus sign. Let me separate these two parts. Okay, so these are our notation, our symbols telling us what to do, and this is us actually doing it. So negative 3 plus 3, well, that's 0. 9 plus 1 is 10. Negative 7, 7. Which means this piece right here is our new row 2. Which means row 1 and row 3 stay absolutely the same. You did not make changes there. You only made changes to row 2. So your new matrix will look like 1, negative 3, 2, 0. And then you put in your new row 2, which is 0, 10, negative 7, 7. And then row 3 stays the same. 2, negative 2, 1, 3. Close it off with your brackets. And this is your new matrix. Okay? Let's look at number 16. Not to work out, but to talk about their notation. So number 16 says negative 3 row 1 plus row 2. Same notation as ours, right? But different matrix. So the first thing you're going to do is multiply row 1 by negative 3. And then you're going to add this result to row 2. Whatever this comes out to be, this is your new row 2. So make sure you leave row 1 and row 3 exactly the same. What does number 17 say? Well, it has two parts to it, right? It says negative 2 times row 1 plus row 3. And then it says negative 5 times row 1 plus row 4. So look at the first one. It says negative 2 times row 1, so that's the first thing you do. And then you're going to add to row 3, which means this is going to become the new row 3. And then the second thing they want you to do is negative 5 times row 1, so go ahead and do that. Add to it row 4, and this will become the new row 4, which means row 1 and row 2 are absolutely going to stay the same. Good. All right, let's keep going. Now, to solve our matrices or our systems of equations, we're going to start using our calculators. Now, depending on what kind of calculator you have, a TI 83, 84, 82, our commands may be a little different. So on the screen, I have a picture of an 83, just in case some of us have 83s. I use an 84 plus, okay? So if you are using the 83, notice right here that it has a key that says matrix. In order to get into your matrix menu, you're just going to hit matrix, and it should take you into a menu. Now, if you're using a different version, so let me go ahead just a little bit, like the 83 plus, which is like the 84 plus and the 84, there's a key that has x to the -1 to the far left, and above it is matrix in yellow, which means you must hit the second key first. So some of us have calculators where there's just a matrix button, and others should have calculators where you have to hit second, then x to the -1 in order to get the matrix menu to come up. And this isn't what your screen will look like. This is just an image from the web. Okay, so for my calculator, I'm going to hit second x to the -1, or you can hit matrix depending on if you have a different calculator. Once you're inside the matrix menu, you're going to scroll over using your cursor key, which is these guys. So you're going to scroll over using him, all the way to edit. Once you're there, just hit enter. I always like to stay with the matrix A unless I have to use other matrices. Alright, so I'm with matrix A. Now you need to tell us the dimensions of your matrix. So let's go back a little bit. What's a good one to go back to? Let's keep going. You know, I will stay forward and I'll explain it this way. So the dimensions of your matrix is the number of rows times the number of columns. So how many rows you have times the number of columns. So let's do an example together. So let's say we were looking at the matrix 3, 1, 4, 2. Okay? Well, how many rows do we have? Rows or horizontal? So we have 2 rows. And how many columns do we have? We have 2 columns. So this is a 2 by 2. So you would hit 2, and then you can use the cursor to move over, or you can hit enter, and that'll move you over. And then you can hit 2 again, and then hit enter. So 2, enter, 2, enter. That should allow you to put in the size of your matrix. And you'll notice that the matrix on the screen actually changes dimensions. Now all you have to do is input the values. So we're still in step 1. So input the values. So the first place should be a 3. Hit enter, and it jumps you over. So now you can put a 1. Hit enter. You fall down. Type in 4. Enter. And then type in 2. Enter. Now once you have your matrix entered, you actually have to get out of the matrix window. So the second thing you want to do is second quit. So here's your second key, and there's quit, which is just the mode. So second quit. And regardless which kind of calculator you have, those should be in the same spots. Second quit or second mode. Now you have to get back inside the matrix menu. So it becomes a game of in the matrix menu, out the matrix menu, in the matrix menu, out. So to get back in, I hit second x to the -1 power, or you hit matrix, depending on your calculator. This time scroll over to just math. Let me take this enter out. That shouldn't have been there. Scroll over to math. And then you're going to scroll down to RREF. RREF. It stands for row reduced echelon form. Okay, hit enter. And then the next thing we need to do is hit second, I do x to the -1, or you hit matrix. You want to get back inside the matrix menu. This time you do not scroll over because you should be in the names. And since we are using matrix A, we can just hit enter. Then hit enter again. And on your screen, you should have 1, 0, 0, 1. Okay? Row reduced echelon form is basically doing matrix operations in order to get 1s along the diagonals and 0s above and below. Okay? Above and below. If it was reduced echelon form without this extra R in it, then we would have just had 0s below and any number above it, right? So this part is very key to solving systems of equations using a calculator and matrices. If you have questions on this part, or if you have a different calculator, please email me and I will explain the steps for your calculator or where you're stuck at. Remember, I crossed out this enter. Do not hit enter after you're in math. Instead, scroll down to row reduced echelon form, then hit enter. All right, let's do an example. So page 875, number 21. It says solve each system of equations using matrices. Use Gaussian elimination with back substitution or Gauss-Jordan elimination. Now, we will not be using those methods to solve this system. Instead, we're going to use our calculator. So number 21. We have the matrix x plus y minus z equals -2. And then we have 2x minus y plus z equals 5. And then we have -x plus 2y plus 2z equals 1. So the first thing we have to do is write it using our augmented matrix. So number 1, you need an augmented matrix. So you're just going to write the coefficients here. Don't forget you have your vertical bar and then your constants. So the first coefficient is 1, 1, -1. Remember, we're looking at the first equation. We have our vertical bar, which is the equal sign, -2. And then the second equation is 2, -1, 1, 5. -1, 2, 2, 1. Once you have your augmented matrix, the second thing you need to do is go to your calculator. You need to input this matrix. So let's turn our calculators on again. Remember, get inside your matrix menu, scroll over to edit, and then hit enter. Now, what is the size of this matrix? Count how many rows you have. So we have 1, 2, 3 rows, because remember, rows are horizontal, and then columns are vertical. How many columns do you have? 1, 2, 3, 4 columns. Don't forget this last column. He's actually important. So you have 4 columns. So this is a 3 by 4. So type 3, enter, 4, enter. Now you need to input this matrix. And you're going to start with the element 1, hit enter. You're going to jump over to here, type 1, enter, etc. So let's do that. 1, enter, 1. Be careful with your signs when you're inputting your matrix. Okay, once you have your matrix inputted, go ahead and double check it to make sure you didn't get any signs backwards. You can go through and check it using the cursor button. You can navigate up and down and right and left. Okay, once we have our matrix inputted correctly, and we trust that we do, you want to get out of the matrix menu, so hit second, quit. Second, quit gets you out of the matrix menu and back to the home screen. Now you need to get back inside the matrix. So go ahead and get back inside the matrix menu. This time scroll over to math, then scroll all the way down to RREF, which is row reduced echelon form. type enter. Now you need to get back inside the matrix menu once again. So get inside the matrix menu, and you should be inside the names. Now if you use matrix A like I did, just go ahead and press enter, and then hit enter again. Okay, so on your screen, if you made it through all those steps, it should say RREF, open up parentheses, and then it says matrix A. Now I just hit enter. If you close your parentheses, you can close it or you can hit enter. There will be no error in there. And then it gives you another matrix, right? So let's write it out. 1, 0, 0, 0, 1, 0. Okay, so this is the matrix that it gives us on our home screen. This is the matrix we started with. And this is our row reduced echelon form. Now we're not done with the problem. The next thing we have to do is write out the solutions for the variables, right? So remember, this is your x column, this is your y column, and this is your z column. So let's start this first row. We have 1x, so I'm just going to write x, plus 0y plus 0z is equal to 1. And then underneath it we have 0x plus 1y plus 0z equals negative 1. And then we have 0x plus 0y plus 1z equals 2. So we ignore all these zeros. What do we really have? We have x equals 1, y equals negative 1, and z equals 2. And that right there is the solution to this system of equations. You can take the point 1, comma, negative 1, comma, 2, plugging in for each x and y and z respectively, and you should be able to, actually, if you plug in the x, y, and z for each equation, you'll end up with the value on the right side. Okay, so that's using a calculator to solve a system of equations. If you got stuck on this problem with your calculator, please email me and we'll go over the steps again.